Here we are just going to explore different pieces of an exponential function, just deciphering rates as a percent from factors given in the y equals c times a to the x formula. So you want to keep in mind in the y equals c times a to the x, that c is the initial amount and a is the growth or decay factor. Not the rate. The rate is a percentage. So it's growth if it's bigger than 1, and it's decay if it's between 0 and 1. So looking at this first formula, r of t equals 25 times 0.05 raised to the t. So the initial amount is 25. Since a is 0.05, this is representing decay. Since a is less than 1, that decay factor is 0.05. And as a percent, we would say we have 1 minus 0.05, which is 0.95, times 100. This is a 95% decay. It's decaying really fast. We're only multiplying by 0.05, so we're getting a much smaller number every time. We're having a 95% decay. I'm going to jump to this bottom one, which is set up very similarly. We have the formula given to us to start, so we just need to break it into pieces. The 24 is our initial value. Since we're multiplying by 1.03, that's a number bigger than 1, so that means we have some growth here. Our factor is 1.03, given right there for us. And we want to figure out what kind of growth this is. So we're going to do 1.03 minus 1. Figure out how much bigger than 1 this is. Instead of less than 1, like last time when it was decay. It's bigger than 1 by 0.03, which when we multiply by 100, represents a 3% growth. So 1.03 is 3% growth, whereas 0.05 was 95% decay. It was decreasing by a lot. Looking at this piece here, we have 300 for our initial value. So we're given a 300 initial value, and we're given a factor of 1.14. So we're going to start by writing a function. I'm going to just call it f of x is 300 times 1.14 raised to the x. So there's writing that into a function. And since we have 1.14, we want to figure out, is that growth or decay? Since it's bigger than 1, it's growth. We want to figure out how much bigger than 1 it actually is. So we're going to do 1.14 minus 1. It's 0.14 bigger than 1. And if we multiply that by 100, that means it's 14% growth each time. If we look at the other one that's set up similar to that, we're given our two numbers here to start. We have 1,005 and 0.15. And so we can write a function out of that. We can call it f of x, or y is 1,005 for the initial times 0.15 to the x. So since our factor is 0.15, is that growth or is that decay? It must be decay, since it's between 0 and 1. So we want to use this piece up here, our last decay we did. We want to figure out how much less than 1 it is, since it's decay. So we're going to do 1 minus 0.15 and figure out that it's 0.85 less than 1. So as a percent, it's 85% less than it was before. Multiplying by just 0.15 represents an 85% decay. So getting very small very quickly. Okay, now we're down to the last two that are similar. So looking at this top one, we have 54 for our initial, and then we don't know the factor yet. We know that it's an 85.6% decay though. So we want to figure out what that factor would be. So first of all, we're going to divide this by 100 to see what we get, which is going to be 0.856. And we want to figure out how much less than 1 that is. So we want to do 1 minus 0.856 in our calculator to figure out what number do we have to multiply by to get a decay of 0.856 or 85.6%. So we're going to multiply by 144 to make it 85.6% smaller, which makes sense because the one below that, 85% smaller, meant multiplying by 0.15. This we want it 85.6% smaller, so we're going to multiply by 1.144. So to write our equation, we have y equals 54 times 0.144 to the x. And then this last one here, we have some growth, and we have the initial value, and we have the rate. So first of all, we're going to divide that rate by 100 to see what it is as a decimal, which is going to give us, when we move it over, 1.28. And we're representing growth, so we're going to add 1 to that. We're going to see how much more than 100% is that. We're going to add 1. It's going to give us 2.28 as our growth factor. And so our equation, which we can call f of x or y, is going to be our initial value 8 times our growth factor is 2.28 raised to the x. So lots of conversion, lots of practice going from percents to growth or decay rates from those rates to the factors that we need for the formula.